Hey there everyone, welcome to the C&S Investigation 2 review. We're going to go ahead and get started with number 1. It says, what is the area of the shape? And it wants to show our work. So to start off, looking at the triangle, we need to identify the two dimensions that we need. So knowing that our formula is area equals half base times height, we know that we are going to need the base of the triangle and the height of the triangle as well. Now there are two ways to find this height. If we think back to when we first started learning about the formula, we remember that we found the height by drawing a rectangle around the triangle. So we found that if we connect the vertices here, the triangle should fit in a perfect rectangle. And now from here, we can identify that the height is from here to here, which in total is 1, 2, 3, 4, 5, 6 squared units. Okay, so we have 6 for our height. And now thinking about the base, if we remember the video that showed us that we want to imagine the triangle sitting flat on a surface. If we think of this as a cone or a mountain, this cone or mountain would be upside down. So our base is actually up here, and we have a total of 4 units for our base. So those are the two dimensions that we need. We have our base and our height. The other way is to connect the very top of the cone or the mountain to the base. We just have to make sure that this is a straight line that runs up and down. Okay, so if we count from there to there, we see that the distance from the base to the very peak of our triangle is also 6. Okay, now that we have this information, we can go ahead and continue into our formula and plug these numbers in. So our second step in our formula would be to write area equals half. And instead of using the variables b and h, base times height, we're going to actually plug in our base, which is 4, and we'll plug in our height as well, which is 6. In our next step, we're going to continue by writing area equals half, and this time we're going to solve what's inside our parentheses here. So 4 times 6 does give us 24. Close our parentheses, and our final step is to multiply that 24 by half, which we know is the same thing as dividing it by 2. So we have an answer of 12 units squared. Okay. Now just remember, if you don't see a unit like inches or centimeters or anything, we just use this U, so that way we're showing that at least we're finding the area, right? So units squared. Okay. Now moving on to number 2. Similar problem here. We're going to have to find the area, but this time we also have to find the perimeter. We know that perimeter means the distance around a shape. This is the same definition for a square, for a rectangle, for a pentagon, a hexagon. So we are going to be looking for the total distance from this vertex to this vertex to this one, and then back down to here. All right, so looking at those purple lines, I see that there are a total of 4 numbers that we need to include. So we have the number 3, 8, 9, and 5. So those are the 4 side lengths. Now this triangle is split in half at the bottom, so normally we would have 1 full side length. We know that 3 plus 8 is 11, but for the perimeter, we can keep these separate and just do perimeter equals 3 plus 8 plus 9 plus 5. We know 3 plus 8 is 11. We know 11 plus 9 is 20, and 20 plus 5 is 25. So we have a total perimeter of 25, and this time we do have a unit of measurement here, which is centimeters, so we will say it's 25 centimeters. Keep in mind, we do not square our answer when we're working with perimeter because there's no length and width to our dimensions. It's just the distance around the shape. Okay? Next, we have to find the area. Now, I'm going to write area over here because I do like a little more space. And we'll start off with the same formula. We'll do area equals half base times height. And then now I can go ahead and add my numbers in. I know half of the base times the height will be this next step. Now the tricky part is that this is broken up into two parts. So we can go ahead and either add a second set of parentheses and say this is 3 plus 8 times our height of 4. Or you can just go straight into the formula and say 3 plus 8 is 11 and do a little bit of mental math there and say 11 times 4 is the base times height. Okay? Which lets us now solve for 11 times 4, which we get an answer of 44. And the final step would be to multiply that by the half. So we get an answer of 22 centimeters squared. Okay? And that gives us the perimeter and the area for the shape all together. So keep in mind here, even though we saw that it included the height of 4 in the triangle, we ignore the height when we find the perimeter. We only worry about the numbers that make up the distance around the shape. The height is helpful for when we find the area of a triangle, okay? So that's very similar to number 4, which we'll see in a second. But first, we're going to go ahead and work on number 3. Number 3 says we want to draw a non-congruent triangle on the grid. We know congruent means identical or the same. And we also know that non-congruent would be the opposite of that. So we have to draw a triangle that does not look the same, but yet still has the same area. So we're going to go ahead and do this. And there's two ways of doing this. We can either imagine our rectangle here again around our triangle. Okay, so our rectangle tells us that the area of the rectangle would be the length and width would be 2 times 3. So this is a 2 by 3, which means the area of that is 6 units squared. And because we know our formula is half base times height for the triangle, we know that half of that is 3. So the area of this triangle right here is 3. We can draw the same rectangle. Okay. And now that I have my rectangle, I know that whatever triangle I draw inside of this rectangle is also going to have the same area. We know that the area here again is 2 times 3. So the rectangle has an area of 6 units squared. But now, if I draw one vertex here, another here, and maybe do one in the middle, if I connect my lines, my new triangle is going to have the same area. Thinking about the formula here, half of 6 is 3 units squared. And now we see that our triangles are non-congruent. So we have accomplished both of the requirements. We have a non-congruent triangle with the same area. We are all good with this problem. Another way to do this, if we want to draw a much different triangle, would be to think about another factor pair that gives us 6. So thinking about factor pairs, I know the factor pairs of 6 are 1 times 6 and 2 times 3. So I could also use, and I'll use a blue marker here, I could draw a 1 by 6. Okay, and this rectangle would allow me to draw a triangle connecting from here to here to here to there. Okay, so this would be a rectangle with an area of 6 units squared, and half of that would give me a triangle with an area of 3 units squared. Okay? So in problem 3, it also wants us to include the area of triangle 1. So I'm going to start again with my formula, which is half base times height. I'm going to go ahead and I'm going to plug in my numbers, and I'm going to look back to my triangle and see that my base was 3 and my height was 2. And now that I multiply these two numbers, I see that I get an answer of 6. And my final step is to multiply that by half, or divide 6 by 2, which gives me an answer of 3 centimeters squared. Okay, now going to my second triangle, I'm going to go ahead and use the longer one that we just found in blue. And I'm going to, again, start with my formula. Area equals half base times height. Area equals half. The base is 1. The height is 6. So I'm going to fill that in as 1 times 6. When I multiply this, I get an answer of 6. And when I divide this by half, I see that I get an answer of 3 centimeters squared. So now my final goal here is to double check to make sure that my areas are the same, which I do see for both triangles 1 and 2. I have an area of 3 centimeters squared. And looking back at the pictures, they are definitely not congruent. So we have accomplished both of the requirements here for this, and we are ready to move on to number 4. Taking a look at number 4, it says Sonia and Brianna drew a large triangle by combining 2 smaller triangles. They each wrote an expression to find the perimeter of the larger triangle. So as we see here, we can imagine that these 2 triangles were separate at some point. They are now put together, and we know that the definition of perimeter is the distance around a shape. So even though these were separate at some point, we are now imagining this as one triangle, one giant triangle, and we are going to connect our vertices here. So we have these 3 points going from here to here to the top and back down to the bottom. So looking at the outside of the shape, I see that there are a total of 4 numbers or variables that we have to add here. And we're going to take a look and see what Sonia added. So it looks like Sonia added the number 6, 7, the letter Y, and the letter X, or the variables Y and X. Okay? So she added the 4 outside numbers. Let's see if Brianna did the same thing or she made any different decisions. So she added the number 6. We'll draw squares for her. She added the number 7. She added the number 4. And she also added the variables Y and X. So it looks here like Sonia added the outside numbers and variables, and Brianna added those same numbers and variables, but also included the height of the triangle. Okay. So our answer, who is correct, we see that Sonia added the outside numbers. It fits the definition, so we're going to say Sonia is correct. And our reasoning is going to be something along the lines of Sonia's correct because she added the side lengths that are on the outside of the triangle. Of the triangle. And we're going to say, and the definition of perimeter says it is the total distance around a shape. Okay? And then you might also be able to add that Brianna included the height, which is not part of the perimeter. So I know this is a pretty long response, but in any given response and any reasoning for math problems, it's always good to add a definition. That's kind of like your evidence in court if you were a lawyer, right? So if you make sure to add that the definition of perimeter is the total distance around a shape, and then you explain yourself around that one person did follow those rules and one person did not, your response would be pretty solid and pretty good to go. So be sure to kind of keep that in mind. Remember the definition of both area and triangle, because you might see one, you might see another, and that's really it. So remember to review this video again or go back to any parts that you kind of felt unsure about, and good luck with the quiz.